Hello everyone, my name is Uljan Bisarinova and I'm a data scientist at the Institute of Smart Systems and Artificial Intelligence. In this video, I'm going to talk about explainable AI using visual explanations. I'll give an overview on this topic. What is visual explanations and why we need them? At the moment, we can observe widespread industrial adoption of artificial intelligence, with machine learning systems demonstrating very high performance. They also cover a significant number of tasks. On the right-hand side, we can see diagrams which demonstrate the share of different sectors which are in the phase of adopting artificial intelligence. Most of the systems seem to be in the evaluation phase. Some systems are already considered to be mature, and some are in their consideration phase. Nevertheless, we cannot deny the fact that AI is already becoming part of industries. This high performance of machine learning models is being achieved via increasing their complexity. There is a trade-off between empirical utility of machine learning models and theoretical level of understanding. While there exist some models which have both high level of empirical utility and theoretical understanding, at the moment deep learning models are outputting the highest level of empirical utility. At the same time, they have low level of theoretical understanding, and thus these kind of systems are considered black boxes. So what's the problem with black boxes? They create uncertainty in the way such systems operate and also lead to ambiguity in adopting them in sensitive and critical domains such as healthcare. Here we come to the term explainable artificial intelligence, which is a field concerned with the development of new methods that explain and interpret machine learning models. Machine learning models which have high level of empirical utility and low level of theoretical understanding, such as deep learning models, they create sense of magic and might lead to the risk of misuse. On the left-hand side, we can see an example of deep learning model, and the goal of explainable artificial intelligence is to be able to explain what's happening at each layer of such deep learning model. Black box models are usually considered deep learning and ensemble models. Also, there exists a term called white box models or glass box models. So white box models are usually considered to be easier to interpret and explain. Examples of such white box models are usually linear and decision tree based models. On the right-hand side, we can see a specific example case of white box model, and this is a decision tree model for determining house location being located in New York or San Francisco based on 7 dimensions. At each level of such decision tree, we can make a decision based on threshold value, and we can clearly see how the decision is being made at each level, and the final level is outputting the answer, whether the house is being located in New York or San Francisco. There is a trade-off between the performance of machine learning model and its ability to produce explainable and interpretable predictions. While white box models are considered to be clear to explain, they usually have low level of performance in comparison with black box models. Currently, we can observe the shift of the focus of the public being occurred from the predictive power of algorithms to the explainable AI. This can be confirmed by the Google Trends Popularity Index, where explainable AI term has been searched more in the last several years. This also can be confirmed by the research output. Research output in the fields of explainable artificial intelligence, interpretable artificial intelligence, and XAI, which is the abbreviation for explainable artificial intelligence, has been increasing in the last several years. Explainability and interpretability. These terms are somewhat close in their meanings and sometimes being used interchangeably. However, there are some differences. Interpretability is the ability to explain or to present in understandable to human terms and is mostly concerned with the cause and effect relationship within the system's inputs and outputs. Whereas explainability is mostly associated with the inner logic and mechanics of machine learning systems. We are going to talk about interpretability techniques, and here comes the taxonomy of interpretability methods. Interpretability methods can be classified and categorized based on several dimensions, and one of them is the purpose of interpretability. So purpose of interpretability can be creating white box model or explaining black box model, enhancing fairness of a model, testing sensitivity of predictions. Also, interpretability method can be model specific or model agnostic based on whether we want to apply the interpretability method on a single model or it can be applied to any type of model. Also, interpretability method can be local or global based on if you want to explain a single prediction or overall model. Based on data input types, we can also categorize interpretability methods, and the input data types can be tabular, text, image, or graph. This table showcases available interpretability methods for explaining deep learning models, and all of them are concerned with explaining black box models. All of them are considered local, so meaning that they're concerned with predicting specific prediction, All of them are model specifics. It means that they can be applied to specific type of model, and there are different data types which can be fed into this interpretability method, and most of them are images, but there are also text and tabular data. And based on the year of release and citations per year, we can see the power of each tool. So here we come to the end of this video where we give an overview of interpretability methods. In the next video, I'm going to talk about the inner mechanics of interpretability methods. Thanks for attention.